Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions. And in this session we are going to find out the domain of this function f of x, that is equal to 3 times sine inverse, and here we have the greatest integer of 1 plus 3x over 5. So this notation, that is the symbol, the square brackets, denotes the greatest integer function, right? So here we'll find out the domain of this function by using an important property of greatest integer function, right? And this problem is going to be an easy problem, and let us see how we can find out the domain of this function using an important property of greatest integer function. So let us start. So now let us take this expression which is inside the square brackets as p. So let us take p as 1 plus 3x over 5. So now we can write this function as 3 times sine inverse of greatest integer of p. Right now, see here we have the inverse sine function. So we'll first apply the properties of sine inverse function, that is the domain of sine inverse function. And we know that from inverse trigonometric functions, if we have sine inverse theta, then the principal value branch of sine inverse theta lies in the interval, that is minus pi by 2 to pi by 2, provided here this theta, it belongs to this interval, that is minus 1 to 1. So we can now write theta is greater than or equal to minus 1 but less than or equal to 1, right? Okay, so now first we'll apply this concept. So here this theta may be taken as greatest integer of p. So here we have the first condition, that is greatest integer of p should be greater than or equal to minus 1 but less than or equal to 1. So this is the first condition while finding out the domain of this function, right? Okay, so now from here we'll apply an important property of greatest integer function, and the property goes like this. If we have a real number, say p, and if we take the greatest integer of this p, and the greatest integer of p, it lies between minus n and n, where p belongs to the set of real numbers, and here this n, it belongs to some integer, right? So here when we have greatest integer of p greater than or equal to minus n and less than or equal to n, where p belongs to r and n belongs to z, then this p, that is this real number p, it should lie, that is it is greater than or equal to minus n but less than n plus 1, right? So here we'll make use of this property, right? And now if we take this inequality, and if we compare this inequality with this one, then the value of n is equal to 1, because here we have minus 1 and here we have 1, right? So n is equal to 1 and p is 1 plus 3x over 5. So now we have minus 1 less than or equal to greatest integer of 1 plus 3x over 5, and here we have 1. So now the value of p is 1 plus 3x over 5. So now substituting the value of p in this inequality, we have here for n1, and here we have 1 plus 3x over 5, and here we have n is 1, so we have 1 plus 1. So now we can also write this inequality as minus 1. Here we have 1 plus 3x over 5, and here we have 1 plus 1, 2. So let us now multiply throughout by 5. So we have here minus 5, then we have 1 plus 3x. Here 5 and 5 get cancelled, and here we have 10. So let us subtract 1. Throughout we have here 3x, and here we have 10 minus 1. So this is minus 6. Here we have 3x, and here we have 9. Now let us divide throughout by 3. So we have minus 2, and here we have simply x, and here we have 3, right? So from this inequality we can conclude that the valid values of x for which this function is defined, that is the domain of this function f of x, it should be given by this interval which is closed from the left and open from the right. So here 3 is not included, right? So we have minus 2, and here we have 3. So the domain of this function is given by this interval, that is from minus 2 to 3, where minus 2 is included and 3 is excluded. Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions, and here we are going to find out the domain of this function f of x, that is equal to square root of sine inverse 4x plus pi by 6, right? So this problem is an easy problem, and here we have to just make use of the principal value branch of inverse sine function, that is the range of sine inverse function. So let us see how we can easily find out the domain of this function using the concept of range of inverse sine function. So let us start. So now from inverse trigonometric functions, we know that the range of sine inverse theta, it belongs to the interval minus pi by 2 to pi by 2. When theta, it belongs to the interval minus 1 to 1. So here we'll use this concept to find out the domain of this function, right? Okay, so now here we have the square root sign. So the first condition is that this entire term, that is sine inverse 4x plus pi by 6 should be greater than or equal to 0. So this term should be either 0 or it should be a positive, because we cannot have a negative number inside the square root sign, because in that case this number becomes a complex number, right? Okay, so sine inverse 4x plus pi by 6 should be greater than or equal to 0. So from here we can now write sine 4x is greater than or equal to minus pi by 6. So taking pi by 6 to the right hand side. So here we have this inequality, right? Okay, now let us come to this range of sine inverse theta function. Now here we have sine inverse 4x. So if we take theta is equal to 4x, then sine inverse 4x should belongs to this interval, that is minus pi by 2 to pi by 2, right? So here we have sine inverse 4x belonging to this interval. So here we have minus pi by 2, and here we have pi by 2. Now see, from this inequality, here sine inverse 4x should be greater than or equal to minus pi by 6, right? So here it is an important point to note that minus pi by 6, it lies between minus pi by 2 and pi by 2. So here we have minus pi by 6. And to fulfill this condition, sine inverse 4x plus pi by 6 should be greater than or equal to 0. Sine inverse 4x should be greater than or equal to minus pi by 6. So here the minimum value of sine inverse 4x should be minus pi by 6, and sine inverse 4x can go up to pi by 2, right? So now we can modify this inequality, or we can merge the inequality, that is sine inverse 4x is greater than or equal to minus pi by 2 and less than or equal to pi by 2. So if we merge these two inequalities, then we should have sine inverse 4x should be greater than or equal to minus pi by 6, but it should be less than or equal to pi by 2, because here sine inverse 4x is greater than or equal to minus pi by 6, and minus pi by 6, it lies between minus pi by 2 and pi by 2. So we have to consider only these two points, that is minus pi by 6 and pi by 2. So now we have this inequality, and from this inequality we have to find out the valid values of x for which this function is defined. So now let us take the sign of each of these three terms. So we have sine of minus pi by 6, and then we have sine of sine inverse 4x, and then we have sine pi by 2. Now sine minus pi by 6. So sine minus theta is equal to minus sine theta. So sine of minus pi by 6 is equal to minus sine pi by 6, and sine 30 degrees is half. So here we have minus half, and here using an important property of inverse trigonometric function, that is sine of sine inverse theta is equal to theta, right? So here for theta we have 4x. So here we have 4x, and sine pi by 2 is 1. So now dividing throughout by 4, we can now write minus 1 over 8, dividing throughout by 4. So 4 times 2 is 8, and here 4 and 4 get cancelled. So we have here 1 over 4. So the values of x for which this function is defined is given by this interval, that is from minus 1 over 8 to 1 over 4. And remember here this interval is closed from both the ends. So minus 1 over 8 and 1 over 4, both the points are also included, right? So this is how we can find out the domain of functions of these types.